It's like when you take your car and, for a checkup, right?
Mhm.
They hook it up to all these machines just to see what's going on.
Yeah.
And quantum computers are even more complex. I mean, way more sensitive
Right.
to any little hiccup. So how do we make sure they're in tip-top shape?
Right. Well, that's what we're looking at today, actually. A new way to diagnose these quantum systems.
Right.
It's called the Sin Information Integral, or SII for short. And we're going to dive into what it means for a company called Intelicore. They're pretty big in the quantum world.
Yeah, they are. So we've got some really fascinating material here about SII. And I think our mission today is to kind of unpack, what advantages it offers, not just for Intelicore, but for the whole field of quantum computing, because I think that's what a lot of our listeners are really interested in. Like, how is this tech actually moving forward?
Absolutely. And these quantum computers, they have this enormous potential, right? We're talking about revolutionizing medicine materials, science, AI,
Right, yeah.
but they're so susceptible to these tiny errors. Any little disturbance, what we call noise, can really throw things off.
Yeah, noise is the big problem everyone keeps talking about.
It is. So having really reliable diagnostics is crucial. That's where SII comes in.
Okay, so let's start there. What exactly is this SIN information integral? I mean, the name itself sounds a little intimidating.
It's actually a really cool concept. It's a completely new mathematical framework that's designed to analyze quantum information.
Okay.
And, the name kind of gives you a hint, right? The sign integral part.
Right.
Well, if you think about it, quantum particles, they have these wave-like properties. The sign integral is a mathematical tool we use to understand waves. So it kind of naturally fits into analyzing how quantum information behaves inside a quantum computer.
So we're not just talking about looking at the physical hardware itself, we're going deeper than that.
Exactly. SII is really focused on the information within the quantum system, how it's behaving, how it might be getting corrupted or lost. That gives us a much more complete picture compared to the ways we've been doing things, which often just look at individual qubits or, specific operations.
Right. So it's more holistic.
Right.
But how much better is it really? Can we quantify the advantages of using SII?
Absolutely. Let's take noise channel identification. For example, current methods are about 70 to 80% accurate at pinpointing where the noise is coming from.
Okay.
SII is projected to boost that to 95 to 98%.
Wow.
That's a significant improvement. We're talking about cutting the guesswork in half when it comes to diagnosing problems in quantum computers.
So much more targeted then.
Exactly. And then there's the issue of information loss, what we call decoherence. This is where quantum information kind of leaks out into the environment and causes errors.
Right.
SII gives us a 20 to 30% finer granularity in measuring that information loss, so we can catch those early signs of a problem much sooner.
Early detection is always key. And what about fixing those errors? Quantum error correction. It's something we hear a lot about.
Well, because SI gives us so much more detailed information about the noise, we can use that to really optimize our error correction strategies.
Okay.
This could mean we need 10 to 15% fewer qubits. Those are the building blocks of quantum computers.
To achieve the same level of error correction. Or it could mean we see a 5 to 10% improvement in the effectiveness of our existing error correction techniques. So either we need fewer resources or we get better results. Either way, that's pretty impressive.
It is. And there's another advantage that I find really fascinating.
Okay.
SII offers 5 to 8% higher precision in measuring how well quantum states are maintained throughout a computation. You know, how well they stay coherent.
Right.
But here's the really exciting part. They've developed this thing called the Quantum Information Coherence Index, or QICI.
Okay.
And SII allows us to quantify quantum coherence with 15% higher resolution using this new index. It's giving us a whole new level of insight into what's happening inside these machines.
So to recap the big wins here, we have a roughly 25% improvement in identifying where noise is coming from, around a 12.5% gain in error correction efficiency, and in this QICI, which gives us 15% better insight into quantum coherence. All right, so all that sounds great, but what does this mean for Intelicore? What's the bottom line here?
Well, the impact on Intelicore is going to be pretty huge.
Yeah.
First of all, they're looking at potentially a 10% reduction in development time for their quantum projects, just from being able to identify and fix errors more efficiently.
And time is money, as they say.
Exactly. We're talking potentially millions of dollars in savings. And on top of that, because their quantum services are going to be more reliable and perform better thanks to SII, they could see a revenue increase of around 15%.
So big financial advantage.
Oh, absolutely. Plus, don't forget the fact that this is cutting-edge stuff.
Right.
It makes them a much stronger contender for research grants and funding.
Hmm.
So, all in all, we're potentially looking at a total financial benefit for Intelicore somewhere between $50 and $100 million over the next 3 to 5 years.
Wow, that's not insignificant.
Not at all. And strategically speaking, being at the forefront of quantum diagnostics with SII gives them a real competitive edge. They'll be able to attract top talent and form key partnerships. Companies that fall behind in this area, they're going to struggle, they're going to face longer development cycles, and their systems just won't be as reliable. Intelicore is really positioning themselves as a leader here by adopting SII early on.
So it's not just about better tech. It's a smart business move.
Exactly.
So to sum it all up, SII is a major step forward in how we diagnose these quantum computers and how well we can understand them. And that translates into some very real benefits for a company like Intelicore.
I completely agree. We're talking faster development, lower costs, and a stronger position in the market. It's really about making sure these incredibly complex machines are healthy and reliable so we can unlock their full potential.
And it makes you wonder what other fields out there could be on the verge of similar breakthroughs just by getting better at, diagnosing and understanding the systems they're working with. It's pretty exciting to think about. And the future of quantum computing definitely looks brighter thanks to innovations like SII.
I think so too. It's an exciting time to be in this field.
It certainly is. Thanks for breaking it all down for us today.
My pleasure. It was great to be here.
And for all of you listening out there, keep those brains buzzing, and we'll catch you on the next deep dive.